Welcome back, guys. In today's session, we are switching over to case 5 on the dashboard. This is our resource adequacy and arbitrage case. You can already see the impact on the returns and on the revenue mix in the waterfall and revenue charts. Part of the capacity revenue now comes from a resource adequacy contract instead of a pure fixed tolling agreement. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the model start file for free and build everything step by step alongside me. The link is in the video description below. Let's quickly cover what we are about to model in the information memorandum again. On this slide, we are still in monetization pillar 1, contracted capacity revenue, but we are now focusing on the resource adequacy and arbitrage for our BESS column. Compared to the full tolling CTA on the left, a resource adequacy contract doesn't pay for every megawatt hour we could theoretically dispatch. Instead, the system operator pays for the part of the battery that counts as reliable capacity for the grid. That accredited slice is driven by the effective load carrying capability, or ELCC. Also, for this case, we assume a 4-hour battery, which is very typical for resource adequacy programs today. And you can see that the contracted capacity is expressed as ELCC percentage of AC nameplate. On top of that, this case adds a merchant arbitrage overlay. However, the arbitrage piece we will focus on in the next lesson. All of these assumptions are already built into the inputs time independent sheet, very similar to what we did for case 1 with the CTA. For case 5, the resource adequacy revenue is turned on. The contract starts at COD, runs for 20 years and pays a fixed $13 USD per kilowatt AC month that escalates with the same index as the CTA, a flat 2% per year in real terms. This price may seem much higher than the CTA price, but since we have to spend almost double the amount of capex to build a 4-hour versus 2-hour BESS, this higher price is actually necessary to make the project's returns acceptable. The main structural difference versus the CTA case is that we now have a 4-hour nameplate duration, and resource adequacy cares about that 4-hour deliverability plus the ELCC path. ELCC, or effective load carrying capability, is modeled as a time-dependent percentage that typically trends down over time as the grid gets more saturated with storage. If you want to go deeper on the resource adequacy concept, effective load carrying capability, net qualifying capacity, and all other acronyms, we have summarized them in the BESS secret sauce PDF. You can download the secret sauce at the beginning of this course. Let's now implement the resource adequacy revenue block on the operations sheet. From a structural standpoint, this section looks almost identical to the capacity tolling agreement we modeled in the last lesson. So we can reuse most of the modeling logic and just adopt it to the resource adequacy part. And similar to the CTA, we will start again with our flag, which turns the contract on or off. And what we will do is just pick up the formula from our previous lesson, copy this one, paste it here, hit F2, and we can see that our time references seem to work properly. The only thing we will have to adjust is our on and off switch and drag this down a little further, because here we will have a new input or calculation part covering the effective load carrying capability. Hit enter. Then let's do the same thing for the price and also for the price on a nominal basis. So we can just pick up those two formulas here. Control C, Control V, hit F2. Here the linkage has worked properly. Then let's look at this one. These two references are picked up as well. And then let's scroll up and see whether this is fine. This seems to be fine as well. So hit escape and we can drag those three formulas over. Control R. Let's see if we missed something here. And yes, there's still a reference to our CTA flag, which is not what we want. So let's actually pick that one up and drag it over after we have adjusted that. And now that we've already pulled in our prices, now we will cover a resource adequacy specific concept, which is our ELCC, or effective load carrying capability. The idea is essentially this: in each year, only a fraction of the battery's nameplate counts as accredited resource adequacy capacity. That fraction is given by the ELCC, for example, 98% in the first year, 97% in the second year, and so on. And to pick up our inputs time-dependent assumptions regarding the ELCC, we will pick up this row here, the applied resource adequacy ELCC, including any sensitivities, which is row 48. And what you can see here is that our year counter starts again with year 1, 2, 3, and so forth. So the first thing we will actually have to do is implement a resource adequacy year counter. And we will do this using an if statement, if, and we will say the sum of our resource adequacy flag, hit colon, and we will anchor the first reference fully, F4, and the second reference we will only anchor to our row. So we will in each period look backwards at the total sum of these flags here. And if this sum is greater than 0, which means the flag is on, then we will look at the prior period year counter, so J143, and add 1 plus 1. Otherwise, we want a 0, close parentheses, and lastly, we will also multiply this by our resource adequacy flag so that the year counter actually stops once the contract is over. Here we can anchor again to our row, 1, 2 times F4, hit enter, drag it over, Control R. And now you can see that we have a nice year counter from 1 to year 20. And this will allow us to use an X lookup to look up the respective year. But before we use the X lookup, what you will notice is that our first year here is 0, and we do not have any inputs in our inputs time dependent sheet for year 0. So what we will wrap this whole X lookup by is an if error statement. So if error, and then we will start with our X lookup. And if this cell here, our year counter, is 1 or larger, then we want to look up a certain array in our inputs time dependent sheet. So we will look at this year counter. And the lookup array is right here, row 45. Let's mark this full row, hit F4 once to fully anchor it. And our return array. Now be very careful, so you choose row 48, which already includes a ELCC sensitivity. Hit F4, and then we can hit comma. If not found, we want a 0, and match mode should be exact, so again a 0. Close parentheses, and then we still have to finish our if error statement, so comma, 0 again, close parentheses, hit enter. Let's drag this over, Control R. And that gives us our ELCC factor. And this is an additional factor that will reduce our fixed capacity payment. And you can see that the later we get in the time series, the lower that value will be, because more and more BESS will be installed throughout the grid, which essentially makes our BESS less valuable to system operators under a resource adequacy structure. The next thing we can pick up is our contracted capacity before any adjustments. And let's try to reuse the same we used here in 128. But before we pick that one up, let's actually fix an anchoring here. So for K123, which is our flag, let's hit F4 2 more times. So we take off our flag, drag it over, Control R, and then we can pick it up, and the anchoring should be picked up properly. Paste it here. And now our flag moves, but we still have to adjust it to this flag up here. Scroll up. And this reference to the gross AC power is still correct, which is for US dollar per kilowatt month products, which is the case for our resource adequacy contract. Hit enter. Then we will again have a nameplate adjustment, which is essentially just an adjustment in case we fall below our nameplate duration. Here, if you recall in the last lesson, we have taken our AC deliverable energy cap per cycle on a megawatt hour AC basis. And you can see now we actually have a 4-hour battery because this is now 800 megawatt hours AC versus 400 in the last lesson. And this is what we guarantee at the point of interconnection. So this should always be 100%. If we ever drop below 100% due to accelerated degradation and no augmentation, then this adjustment factor would pick this up. So let's copy this value here from our CTA and paste it down here. Hit F2, adjust the reference to our flag. The other two references are still fine. And hit enter. And if you recall, the capacity after nameplate adjustment was a simple multiplication of those two values here. So let's just multiply these two and drag all of these three guys over for now. Control R. So here our nameplate capacity is still 200,000 kilowatt AC at the point of interconnection, similar to the CTA case. The only difference is that we now have a 4-hour battery instead of a 2-hour battery, which means we can essentially supply energy for double the length. And the capacity after the ELCC is something new, and this one is rather simple as well. So we take the capacity after nameplate adjustment and multiply this by our ELCC factor up here. Hit enter and Control R. And you can see that after the ELCC adjustment, our extra capacity, which will be the base for our revenue, shrinks as time passes and the ELCC factor declines as well. Then for our last two adjustments, let's see if we can simply pick up these two formulas here. So hit Control C, paste them here, hit F2, and the reference here seems to be right. We pick up availability, multiply it by our switch, whether this is applicable or not, and multiply it also with our capacity after the ELCC. So that's right. Hit F2 here. This one is for our curtailment adjustment, and we pick up curtailment in row 33, or better 1 minus curtailment, and multiply this by our capacity after availability. And since this switch here is off, we don't even apply any curtailment adjustments to our capacity revenue because the system operator will still pay us the resource adequacy price even if we are curtailed. But that switch introduces flexibility, so you can assume curtailment reducing your resource adequacy revenue or not. So hit enter and let's drag those two over, Control R. Once we have passed through ELCC, availability and curtailment adjustments, we end up with the net qualifying capacity. And that's a capacity that actually earns the money. And we will have a simple linkage for this one again. So we take just the value in row 152, drag it over, Control R, and that now will allow us to model our resource adequacy revenue. So this is a very similar formula to our CTA revenue. What we use as basis is our net qualifying capacity for our resource adequacy revenue stream. So pick up row 153, and then we'll multiply this with our resource adequacy price on a nominal basis, so after inflation. And again, this price is in US dollars per kilowatt AC per month, which means we have to multiply it by 12 or months year. So type in months year, and let's divide this by 1,000. Since this price is in USD and this output here is in thousands USD. Hit enter and let's drag this one over, Control R. Okay guys, and that completes the resource adequacy review for case 5. And we have essentially reused most of the CTA logic, so there was not too much new here. But what we have done, which is resource adequacy specific, is layering in an ELCC so that only accredited capacity earns resource adequacy payments. And in the next lesson, we will build a merchant arbitrage component that sits on top of this resource adequacy structure and also drives the additional upside you saw in the revenue chart earlier. Okay guys, I will see you there.